Dear students, welcome to today's class. So, last 4 days onwards, I am explaining the very fundamental concepts of set theory. In this class, I am going to explain some problems which are related to set theory. Okay, so let us see the first problem. The first problem is A is equal to 8 power n minus 7n minus 1, where n belongs to natural numbers, and B is equal to 49 times n minus 1, n belongs to n, where n is a natural number. So, it is given in a set builder form. So, if you convert it into roster form, you can get the elements which belongs to A and which belongs to B. By seeing those elements, we can decide whether A is subset of B or B is subset of A. Okay now. So, if you observe here, the second set is clearly the second set 49 times n minus 1. 49 times n minus 1 is the second set contains the elements which are multiples of 49 clearly. So, n belongs to n means first you substitute 1 minus 1, 0, 49 into 0, 0. Substitute n is equal to 2 minus 1, 149. Next to 49 into 3, 49 into 4, 49 into 5, like means. So, the set B contains all the elements which are multiples of 49. It is very clear, no doubt. But what about A? So, to decide that, first to see this 8 power n. Can I write down this as 7 plus 1 whole power n? Right. So, see this here by binomial theorem, you can say that NC0 into 7 power n plus NC1 into 7 power n minus 1, NC2 into 7 power n minus 2 plus so on. Last term is NCn into 1. Its previous term is what you will get NCn. No? So, next term is NCn minus 1. This is a 7 power 1. Next term is, previous term is NCn minus 2. This is you will get 7 square. So, this is 7 power 0, 7 power 1, 7 square from last that we did. So, if you observe here, so write down these terms as it is NC0 7 power n, NC1 7 power n minus 1 plus so on. So, this is how much? 7 square 49. This is a 49 into NCn minus 2 plus NCn minus 1 is nothing but n 7n plus NC1 is value is 1. So, understand 1. So, what I am going to do is last two terms observe here 7n plus 1 take to left hand side. So, this is equal to 8n minus 7n minus 1. From the remaining all the terms, can I take 49 common outside? Here also you will get 49. So, here also 7 power, if you take n is equal to 2, 7 square 49, 49 everywhere you will get 49. So, that is equal to 49 into some integer. So, 8 power n minus 7n minus 1 is nothing but 49 into some integer. That means, set A is also contains multiples of 49. Set A also contains multiples of 49. Therefore, clearly A is the subset of B. Okay. So, your answer is A is subset of B is the correct answer. Okay. I hope that you understand this solution. Let us go for next problem. Dear students, welcome back to second problem. If sets A and B are defined as A is equal to x comma y such that y is equal to e power x, where x belongs to R, and B is a set containing the elements x comma y such that y is equal to x, where x belongs to R, right. So, this type of problems can be solved using graph. Okay, very easy. So, don't try to take x value, y value. So, put it, and here also put, no need to convert it into roster form. Okay, right. So, you can draw the diagrams. So, easily you can answer this question. See here, observe this. So, x axis and y axis. Y is equal to e power x graph, we know that. So, this is y is equal to e power x. It passes through the point 0 comma 1, x is equal to 0, y is equal to 1. Okay, now very clear. Y is equal to e power x, exponential graph, you know. Y is equal to x is a straight line passing through origin. So this is y is equal to x is a straight line. Okay, and moreover here x coefficient is positive. That means y is equal to x is a straight line passing through origin and lies entirely in first quadrant and third quadrant. If you observe, there is no chance of intersection here. So there is no chance of touching both the curves. Therefore, their intersection is null set. So A intersection B is null set. Okay, now. So by using the graph of these two curves, you can easily decide that these two curves will be never equal. So as x value tends to infinity, y power e power x value also goes to infinity, but y is equal to x is always a straight line. Okay, na? So I hope that you understand this solution. Okay, let us go for next problem. Dear students, welcome to third problem. If sets A and B have 3 and 6 elements each, then the minimum number of elements in A union B is. So very nice problem this is. Just by already we have explained one concept, that is, so once again I am reminding that concept. If n of A is equal to P, n of B is equal to Q. That means if A contains P elements and B contains Q elements, then minimum of number of elements in A union B, number of elements present in n of A union B is maximum of PQ, maximum of PQ. Okay. What is the maximum number of elements present in n of A union B? It is nothing but P plus Q. Okay, now? Right. Minimum number of elements present in n of A intersection B is equal to 0. What is maximum number of elements present in n of A intersection B is equal to minimum of the values of P and Q. From this information we have, you can say that what is asking minimum number of elements in A union B. What is minimum number of elements in A union B? Maximum of PQ. What is the maximum of PQ? 3, 6. Which is the maximum? 6. 6 is your answer. That's all. So how, sir? Let us see this. See here, A and B are, unless otherwise stated, you have to say that A and B are overlapped sets only you have to take. Unless otherwise, if it are disjoint sets, definitely in the problem they will mention. So here A contains 3 elements, A contains 3 elements, B contains 6 elements. Those 3 elements can I put here? Yes, A contains 3 elements and B contains 6 elements. I can put 3 here. Okay, now, so you can put 0. So total this is 3 and total this is 6. 0 plus 3 plus 3. So n of A union B is equal to n of A plus n of B plus 0 plus 3 plus 3. Total how much? 6. So n of A union B, the minimum number of elements in A union B is equal to 6. What about maximum? Maximum elements means A. So this is 3 elements, then 6 elements. Here you can put 3 and here put 6. You can 6, 0. 3 plus 0 plus 6, 9. That means P plus Q, 9. 9 is your answer. If it is a maximum asked. If it is a minimum, maximum of this PQ. If it is minimum, 3 plus 6, 9. Understand this? Okay. So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to fourth problem. If n of mu is equal to 60, n of A is equal to 21, n of B is equal to 43, then the greatest value of n of A union B and the least value of n of A union B is asked. But try to understand here, observe here n of A is equal to 60, n of A is 21, n of B is 43, 21 plus 43 is equal to how much? It is equal to 64. So it is more than 60. You may get one doubt. That means 4 students are out of the case, out of 60 students, but there we are getting 4 students. Extra we are getting 4 students. So to do this problem, the greatest value of n of union is nothing but So greatest value of n of A union B is what? It should not cross 60. It should not cross 60. That is equal to, that is nothing but n of U union is equal to 60. What is the least value of n of A union B? The least value of n of A union B is nothing but we have the formula maximum of 21, 43, which is the maximum 43. So your answer is 60, 43 is the right answer. Understand this? Okay now. So if you see this problem in the diagrammatic way, so this is A is equal to 21 and B is equal to 43. Okay, 21 should be there, here 43 should be there. So you can put it here 0, 21 here, 0, 21. So here you can put 22. So total, the least value is how much? 0 plus 21 plus 22, 43. What is the maximum value? Maximum value. So this is 21 and 43. But don't keep 0 here. Why? Because if you keep 0 here, 21, 43, it will cross a 60. So extra how much is there? 21 plus 43 means 64 is there. That's why keep 4 here. So remaining how much here? This is a 17 and this is a 39. So if you added 17 plus 4 plus 39, it is equal to 60. Understand this? So this is the concept. So be careful while n of A union n of mu is equal to 60. So that is also 60. 17 plus 4 is equal to 21. 21 plus 39, 60. So this is a greatest value and this is the least value. Okay. I hope that you understand this solution. So let us go for next problem. Dear students, welcome to fifth problem. Let A and B be two sets, then A union B whole complement union A complement intersection B. So by seeing this problem, don't get any tension. So you can apply the formulas and otherwise you can draw the Venn diagrams also you can draw. So first you apply the formula, but it is easy to solve this problem using formulas. First A union B whole complement. We have the De Morgan's laws. That is A complement intersection B complement union A complement intersection B. Understand? So this is the formula that we have. First I applied the De Morgan's laws. Afterwards, it is a distributive law is there. Distributive law is there. Now see here. What is the distributive law? For example, A intersection B union C is equal to A intersection B union A intersection C. One formula is there. Same, just like same. It is there, no? In place of, is there any distributive formula we can apply? No. It cannot. Why? Because here B complement is there, here B is there. You cannot apply the distributive formula. And yes, you can apply. So you can take it as a C. You can apply easily. So this is can be written as A complement intersection B complement union B. See here, distributive formula. A intersection B complement union A intersection B complement. So if you observe A intersection is nothing but B complement union B is nothing but universal set mu. So A complement intersection mu is nothing but A complement. So your answer is A. So this type of problems can be done very easily using De Morgan's laws and distributive laws and here identity laws. Three laws I applied. De Morgan's laws, distributive law and identity law I applied here. Okay now? So idempotent law I applied. Okay. I hope that you understand the solution. So let us go for next problem. Dear students, welcome to sixth problem, which is the simplified representation of one set is given A complement intersection B complement intersection C union B intersection C union A intersection C, where A, B, C are the subsets of set X. Answers are given. So here, so to do this type of such a big expression in sets, first see that let us simplify one by one. First here A complement intersection B complement intersection C is there. Here B intersection C union A intersection C. If you observe up to here, you can apply the distributive law. You can apply the distributive. All formulas from left hand side to right hand side and right hand side to left hand side also you have to learn. Okay, here you can apply the distributive property. How? C intersection B union C you can write down. See here, C intersection B union C intersection, sorry, B A, you can write down A here. You can write here. C intersection B union C intersection A. Up to here I applied distributive property. Here you observe, here A union B whole complement intersection C. A complement intersection B complement is nothing but A union B whole complement, De Morgan's law. And this is union C intersection B union A. Okay now? Right. Again, if you observe here, C intersection, again you can apply distributive property. That is a C intersection. This is A union B whole complement union B union A. B union A. Apply here distributive property. See here we have a property A complement union A is nothing but universal set. It is nothing but universal set. That is equal to C intersection. This is nothing but universal set mu. Okay na? Universal set mu. C intersection mu is nothing but C. So therefore option C is your right answer. So here what did we think is all formulas in a reverse way we applied. So here also distributive property. Again this is De Morgan's property. Again this is distributive property. And here identity laws we applied here. Okay na? So very easy problem. So if you have the command over all the formulas, you can do these type of problems very easy. I hope that you understand the solution. Let us go for next problem. Dear students, welcome to 7th problem. A survey shows that in a city that 63% of the citizens like tea, whereas 76% like coffee. If X% like both tea and coffee, then here what are the options here given, you see clearly. So here some inequality signs are also given. So you may get a doubt that generally what are the inequalities in set problems also, as we will get some inequalities also. First thing what you have to get from this problem is, in a city some persons are there, out of that 63% like tea and 76% like coffee, but there are some persons are there who do not like both tea and coffee. Understand that percentage of persons are also will be there. Those persons are will be there who do not like both tea and coffee. That should be keep in mind. So from this Venn diagram, so this is A and B. So let us say that so this is A intersection B. N of A intersection B is always less than or equal to A, and also N of A intersection B is always less than or equal to N of B. That should be very clear. A intersection B, number of persons who like both tea and coffee are always less than N of A and N of B. Those who like tea and like coffee. This is the inequality that you should learn. And one more inequality that you have to learn is, if there are 100 students are there, 100 persons are there in a locality, that N of A union B is less than or equal to 100. N of A union B is less than or equal to 100. Why? Because there are some citizens are there who do not like tea and coffee. Okay, now we are concerned only about the citizens who take only tea and coffee. Tea takes 63%. That means 63 citizens they like tea, and 76 they like coffee. But there are persons who like both, who do not like tea and coffee. Okay, right. So this is the inequality we got. Or let us start our problem. So N of A union B is, so we have the formula N of A, that is 63, plus N of B, that is 76, minus N of A intersection B is less than or equal to 100. From this, how much? 63 plus 76. So 63 plus 76 is, this is 9, 139. Understand? So 139, if it is comes here, if it goes nice, so n of A intersection B. So this is greater than or equal to 39. So this is the first inequality we got. Okay, now call it as 1. The second inequality that we are going to get is, see here, n of A intersection B. N of A intersection B is less than or equal to n of A. N of A means how much? 63. Again, n of A intersection B is less than or equal to n of B. N of B is equal to how much? 76. From these two inequalities, if you draw on a number line, this is 63 and 76. N of A intersection B is less than 63. This is 63 less than 76. What is the common part? From these two common part, n of A intersection B is less than or equal to 63. So we call it as second inequality. Okay. So if you combine first inequality and second inequality, that is n of A intersection B is greater than or equal to 39, n of A intersection B is less than or equal to 63. So option D will be your correct answer. That means X lies between. X means what here? X percentage like both tea and coffee. That means n of A intersection is nothing but X. That is 39 less than or equal to X less than or equal to 63. So this is your answer. So from this first, to do this type of problems, the first thing what you have to be remember, that is, there are some persons are there who do not like both tea and coffee. That you should remember. And one more inequalities, two more inequalities that you have to remember is this. Okay, na? So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to 8th problem. If A is a set containing the ordered pairs x comma y, I will tell what is meant by this is a ordered pair. The next chapter relations is there. There we will come across here. So y is equal to 1 upon x, where x not equal to 0 and x belongs to real numbers. And B is a set containing ordered pairs x comma y such that y is equal to minus x, where x is belongs to real numbers. Then what is about their relation? A intersection B is equal to A now, A intersection B is equal to B, or A intersection B is equal to null set, A union B is equal to A. So this type of problems can be solved using by drawing the graph. So this is x-axis and it is y-axis. So what is the graph of y is equal to 1 upon x? So the graph of y is equal to 1 upon x is given by this. So this is the graph of y is equal to 1 upon x. That means as x value increases, the y value decreases and it tends to plus infinity. Here also, as x value decreases, and your y value is also goes on increases, y value goes on increases. Understand? So this is the graph of y is equal to 1 upon x. Okay, right. What about y is equal to minus x graph? Y is equal to minus x graph is a straight line passing through origin, and if you observe here, so this is y is equal to mx form, where m is equal to minus 1, which is less than 0. That is angle is 135 degrees. The line makes angle 135 degrees. So this is theta is equal to 135 degrees. So tan theta is minus 1. So if you observe, is there any chance of intersecting these two curves? Is there any chance of intersecting these two curves? No. That means there won't be any common element for this both the curves. That's why, therefore, your answer is A intersection B is equal to null set. So if you have the command over drawing the curve, some basic curves, y is equal to 1 by x, y is equal to x square, y is equal to e power x, y is equal to a power x, y is equal to x, y is equal to minus x, y is equal to some x square plus 2x plus 3, such type of basic graphs, this type of problems you can easily solve. Okay, na? So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to 9th problem. So it was asked in 2015 JEE mains examination. So the question is here, P is a set containing the theta such that theta satisfies this equation. Sin theta minus cos theta is equal to root 2 cos theta, and q is equal to sin theta plus cos theta is equal to root 2 sin theta, be two sets. Then what is the relation between these two sets he is asking. P subset of QR and Q minus P not equal to null set, such that different options are given. But so let us see this first problem. Sin theta minus cos theta is equal to root 2 cos theta. So let us divide with here theta does not given anything. So hope that this equation will satisfy different values of theta. So let us divide with cos theta. So sin theta by cos theta is how much? Tan theta minus 1. So this is equal to root 2. So for this is tan theta is equal to root 2 plus 1. This implies theta is equal to 67.5 degrees. Okay na? Right. Second one. So you divide with second one. So you divide with sin theta. This is a 1 plus cot theta is equal to root 2. This implies cot theta is equal to root 2 minus 1. This is also 67.5 degrees. Cot of 67.5 degrees is equal to root 2 minus 1. Tan of 67.5 degrees is also. So that means A also and A and B contains the same angle, 67.5 degrees, 16.5 degrees. From this we can conclude that P is equal to Q is our right answer. Okay na? Right. I hope that you understand this solution. So let us go for next problem. Dear students, welcome to 10th problem. If X is a set containing the elements such that 4 power n minus 3n minus 1 is equal to where n belongs to natural numbers, and Y is a set 9 times n minus 1, n belongs to n, then X union Y is equal to how much? So this was asked in 2014 mains, a very easy problem. First thing, from the set Y, you can say that 9 times n minus 1. That means 9 into 0, 9 into 1, 9 into 2, 9 into 3. That means what? So the set contains multiples of Y. The set contains multiples of Y. Okay na? Right. Coming to what about X? The set containing multiples of 9. The set containing multiples of 9. Right. What about 4 power n minus 3n minus 1? So 4 power n can be written as 1 plus 3 whole power n. 4 can be written as 1 plus 3 whole power n. So binomial theorem. So you can expand NC0. So this is NC0 into 1 power n minus 1 into plus next one NC1 into 1 to the power of 1 into 3, right? NC2 into 3 square. So on, last number is NCN into 3 power n. Up to that you know, right? So NC0 is equal to 1 plus NC1 is equal to n. This is equal to 3n. So from this you can say that this is 9. NC2 into 9 plus so on, last one NCN into 3 power n. This is 4 power n plus 1 plus 3n. Take to left hand side. 4 power n minus 3n minus 1 is equal to, from here onwards 9. Next what you will get here? 3 square. Next 3 cube, 3 power 4. Like that 3 power n means what? From this all things you can take 9 into some integer. 9 into some integer. That means what? The second set is also containing the elements multiples of 9. Second set is also contains the elements which are multiples of 9. That means clearly X is you can write down, n is equal to 1, n is equal to write down, you can write down. But here clearly X is subset of Y. When X is subset of Y, X union Y is equal to, so this is a X and it is Y. When X is subset of Y, X union Y is nothing but Y. Therefore your Y is your correct answer. Okay na? So this is a problems. Dear students, I think I hope that you enjoyed today's class with some more problems which were given in previous JEE mains examinations. I will come before you. So until then, all the best.